Guys, we're doing an example now in chapter 12. I did this before, but I forgot to share it. So let me share it. And the example is chapter 12, number 2. So let's begin. Click on this. Okay, so read the example. A company is trying to market a new men's deodorant. 40% will ultimately try this brand. And of those, 65% will purchase it. And this brand will attract heavier than average. In fact, 25% more, so there's a bonus of 25%. New brand is uncertain. Okay, the percentage of new purchases is uncertain, meaning it has an average of around 40, appears at 40%, but there's a standard deviation of 5%, meaning it can be 45%, 50%, 35%, 34%. It varies. So that's where the Monte Carlo simulation comes in. We can very easily predict what the average is going to be. It's going to be 40% times 65% times 125%, a bonus of 25%. But that's just the average. What about the highest number, the lowest number, the median number, the 75th percentile? Because you need a range of possible answers to make a business decision. So the best way to do that is through running a Monte Carlo simulation. Now, like all the simulations in this chapter, the book doesn't expect you to do the simulation. They actually give you the results of the simulation and merely ask you to calculate the average at the maximum, the minimum. That's easy in Excel or StatCrunch, but they want you to be able to set it up. So let the T be the proportion of customers who are trying the brand, R be the proportion who make repurchases, and B be the buyer index, which is 1 for the average. But since now we're 25% above the average, it's going to be 1.25 for our example. So the long run market share, this is the first step of the simulation, is to realize that you're supposed to multiply them. It's the T times the R times the B. Now, in algebra, you put letters next to each other if you don't need a asterisk or a dot. So this is the first answer. The value of T, that's the one that we're told is unknown. It's around 40%, but it's at any time in any particular instance, it could be anywhere close to 40%. So T is randomly distributed. And the way you distribute a random number in Excel, which is the basis of the simulation, is to use this formula where this rand generates numbers between 0 and 1. We want to scale them to an average of 40. So you put in 40% here. Whoops, where are we? Where are we? 40% goes here. And the oops, 40. And 5% goes here. Now it might be 0.4 and 0.05. Let me think. The values in alphabetical order are, oh, well, I guess that was the T. So the B is going to be 1.25. We'll find out in a second if the book wants. And the other one was 0.65. The other one meaning the B. I mean the R. So T B is okay. Now if these are percentages, let's put them decimals, I should say. Let's make this a decimal. 0.40 and 0.05. Let's cross our fingers and Check. Yes. Now the rest of it is quite easy. The mean is, well, we have the numbers. I prefer to open this in StatCrunch because it gives you averages and all the relevant statistics very easily. And Excel's pretty easy also, but the StatCrunch just takes a second. This is the variable. Oh, sorry. You went stat, summary stat, columns, click on var1, and that's it. Compute. And we now know the mean is 32, which, by the way, if you multiplied, so 32.20. And again, it's not, this is already, these numbers are given to you as percentages. So you want to give them the answer in percentages. And that's right. Done. The standard deviation, which is, okay, remember that if you multiplied 40 times 1.25 times 0.65, you will get something very close to 32.32. But now we're going to be getting the variation. How much variation could we expect? Well, again, we go back here. The standard deviation is 3.79, 3.769. Down here, Control V, Enter. So far, so good. A minimum, which is also an important statistic to have in this context. So the lowest we can expect is 22.73% based on the simulation results that they give you. Check answer. Maximum, a little tedious, but nice to get these answers right. Control C, Control V, Enter. And we're done. Okay, that's a wrap.